You Hi, everybody. Thank you for joining. I am so excited you're all here to join us for Demo Day. It has been quite a year, and this is the culmination of our 2020 Incubatenergy Labs program. We have over 600 registered for the day today, so great to see such a fantastic audience. As we kick off the day, a quick note on the Hub platform. I put this in the chat as well. Use the chat function to engage in real time. All of you are muted on the platform, so use that chat function regularly. All of the teams and project members are monitoring that so they can respond as you chat those. And then if you'd like to touch base with any of these companies or project members in more detail, use the Meetings tab on the left nav bar. I would like to thank the 11 utilities and the 10 startups who have run these demonstrations that you'll be learning about today. And I'm super happy to be joined by my co-host, Steve Kidwell, VP of Innovation at Ameren. Ameren is one of our host utilities for 2020, led 4 of these demonstrations, and is hosting our demo day today. Steve, it's a tremendous pleasure to work with you and in general, and especially here on our demo day. And Steve, you are on mute.
Thank you. We had to have somebody do that, right? So, yeah, it's a pleasure to be working with you as well, Eric. Great to be here. I want to add a shout out to the EPRI team for all the work to get us here. It's really an example of the great collaborative model that EPRI has, and another great example. Ameren is very pleased to be here and great to be part of this. Without further ado, it is my great pleasure to introduce Ameren's CEO and one of our industry's true leaders, Warner Baxter. Warner's consistent championing of innovation and our partnership with EPRI have both been critical in getting us all to this day. Warner, the floor is yours.
Good afternoon. I'm Warner Baxter, Chairman and CEO of Ameren, and on behalf of all of our coworkers at Ameren, I want to welcome you to the 2020 Incubatenergy Labs Demo Day. Today is the exciting culmination of this year's program, and so I'm so pleased that you joined us today. But today's Demo Day is a little different from past year's programs. As you can see, we're conducting it virtually, but for good reason. So while we had hoped to host you in my hometown of St. Louis to celebrate the success of this year's participants, safety is one of our core values in Ameren, and it's one that we never compromise. So here we are, appropriately using innovative technology for our demo day. But to be clear, we're no less excited to virtually showcase the remarkable talents and innovative achievements of the 10 energy startups involved in the program this year. I have to say, there has never been a more exciting time to be engaged in the energy industry. And more specifically for us, the utility industry. The amount of change and transformation taking place in our industry, well, it's never been greater. This transformation is being driven by the fact that our customers' energy needs and expectations, they have never been greater. Our customers expect safe and reliable energy, and I mean near perfect. They also want the energy we deliver to be affordable, and they, along with many other stakeholders, they want it cleaner. So simply put, they care about the environment and our sustainability plans, including our industry's plans to transition to a cleaner and more diverse portfolio to reduce carbon emissions. And they know that we are the experts in this space, and so they rightfully expect us to meet these rising expectations and to do it seamlessly. So that is why I often remind our coworkers that we're not only in the energy business, but we're also in the customer business. And so our goal at Ameren is to meet our customers' energy needs and exceed their expectations. And this is why there's never been a more important time for even greater innovation in our industry. Our customers and key stakeholders' expectations, they continue to rise. And so do the challenges to meet and exceed those expectations. And to be clear, so do the opportunities. So this is why we're here today. The Incubate Energy program is designed to bring innovative products and programs to the table that will enable us and other stakeholders in our industry to meet and exceed our customers' rising expectations today and in the future. It's designed to help all of us address challenges and to capitalize on those important opportunities. So that's why I'm so excited about the program. And this is why Ameren is in its 4th year of its Accelerator program. It's so that we can help foster, support, and advance the best energy technologies the market has to offer. Since day one of our Accelerator program, we have sought out the best and the brightest entrepreneurs from around the world. We have designed our program so that coworkers directly engage with these entrepreneurs, because at Ameren, we like to say our innovation team, it's over 9,000 coworkers strong. And we don't just talk about innovative energy solutions, we test those solutions right here. To date, energy startups involved with our program have innovated in areas of battery technology, energy efficiency, grid resiliency software, and a host of other clean energy and smart grid technologies. So let's take a moment to hear a few of the success stories from our program so far.
My name is Ugwa Maneo, and I'm the co-founder and CEO of Shift Power Solutions. Shift is an energy technology company that builds IoT and integrated energy management software to connect and intelligently manage distributed energy resources, but with initial focus in markets that are struggling with resiliency. So our initial market's actually Nigeria, but where a really unreliable grid means that many people rely on distributed resources for much of their power.
My name is BJ Johnson. I'm the co-founder and CEO of ClearFlame Engines. ClearFlame modifies the diesel engine design to be able to use lower carbon alternative fuels like ethanol. This allows us to preserve all of the performance and practicality of the diesel engine, but decoupled from the cost and emissions challenges associated with petroleum diesel fuel.
My name is Paris Moss, and I'm the CEO and co-founder of Eden Geotech. We are a sustainable petroleum reservoir stimulation company based out of Greentown Labs in Somerville, Massachusetts.
Shortly after leaving the accelerator, my co-founder Cole and I were nominated as Forbes 30 Under 30 in the energy category. We are currently doing a $2 million seed raise. Probably by the time you see this video, we would have closed.
Since we completed the Ameren Accelerator, we closed a $3 million equity seed round, secured another $1.1 million in contract R&D from the Department of Energy in partnership with Cummins, and have signed a lease to expand our R&D work into the west suburbs of Chicago.
Since graduating from the program last year, we have raised more than $1.1 million in capital. So we use that capital to hire full-time scientists to join our Eden team. And we have secured a paid pilot opportunity in Oman for $500,000.
I think one of the best things that we took away was the relationships we formed with other participants, other startups. Their networks, their insight, being able to brainstorm and think through challenges together was really valuable.
Just to learn as much as possible. You never know what skill you're going to develop that's going to pay dividends for you as a CEO down the line, nor do you know who at a utility is going to ultimately prove to be that key connection in getting you a pilot demonstration in the future.
It's not a competition of sorts, so really being able to share what challenges you have and being open will allow you to get the help and the feedback that can be really beneficial in the long run.
As you can see, several of the companies engaged in our accelerator program, well, they're already off to a terrific start. And I have even greater expectations for this year's program. So that's why we're so happy to partner with one of the world's leading innovators, EPRI, and the Incubatenergy labs to foster the innovation that is so important for our customers, the communities we serve, our country, and frankly, countries all over the world. And so as I wrap up, I want to take a moment to express my appreciation to many organizations that have helped make this program possible, including, of course, our partners at EPRI and Incubatenergy labs, our fellow utility hosts, American Electric Power and TVA, as well as the 8 other participating utilities, the many coworkers from each of the participating utilities, and of course, the 10 startup companies that you'll hear from today. All of you have my sincere gratitude for a job very well done. And so finally, I have one other person I want to express my sincere appreciation to. That's EPRI's current CEO, Mike Howard. As many of you probably know, Mike will be retiring at the end of the year and passing the torch on to EPRI's current president, the very talented Arshad Mansour. And when people speak about innovation and leadership in the electric energy industry, one name that is always at the top of the list is Mike Howard. Now, Mike has been a recognized leader in so many fronts, far too many to name here. But one area is certainly the Incubatenergy program. He's been a champion of this program from the very beginning. You know, Mike recognized EPRI's unique ability to bridge the gap between new energy innovations and the needs of our utility customers each and every day. His vision, creativity, and leadership have laid a foundation for continued growth and success of the Incubatenergy programs. And so, Mike, I want to personally thank you for your incredible leadership. Speaking on behalf of Ameren and the entire industry, we're sincerely grateful for your decades of contributions to our industry. And so now it is my great pleasure to introduce to you EPRI's CEO, Dr. Michael Howard. Mike, the floor is all yours.
This is Mike Howard, and I want to especially thank Warner Baxter for that introduction. I also want to thank Warner for the many years of service that he has been on the EPRI board, and also as former chair of the EPRI board of directors. Under Warner's leadership at Ameren, it's really set the example of how a utility engages with EPRI to collaborate on new technology innovations that really help to ensure that we continue to provide safe, reliable, affordable, and cleaner energy for everyone. I also want to thank Ameren for their accelerator support as host of this year's Incubatenergy Lab startup demonstration programs. And finally, I want to thank you for participating in today's event. Now, while Incubatenergy provides a platform for utilities to come together, it also provides an opportunity for the startup community to really help demonstrate the viability of their new technology innovations for the broader industry. It's also to hear an opportunity to really hear from others and from that help to really refine your innovations to make them even better. The combination of you, the utility companies, and others in the startup community is really unparalleled, and so coming together it provides the ability for everybody to learn and really help make your ideas even better. And I encourage you to take advantage of this collaboration to help make your ideas even better for the overall marketplace. Now, this has been an unusual year, and while we're living through this really unusual time, it demonstrates the value of innovation, certainly resiliency and cooperation through working together. We started this year envisioning that we would have face-to-face activities and be able to test the solutions across really a variety of spectrums, from grid modernization to electrification to customer resiliency and much, much more. But as you know, things didn't turn out as planned, and we found ourselves quickly pivoting and trying to rethink about how we can engage with the utilities and the startup communities. And in the discussions with the group, really didn't miss a beat. Came together, identified some ways to be more creative and agility and determination to really make this shift so we could still figure out a way to collaborate. And as we join together today, from a distance, we continue to work together to try to shape the technology really for the benefit of the industry and for society as a whole. And so the role of electricity, the role that you are playing to help enhance the value of the technology together, is critically important. The companies participating in this Incubatenergy Lab Challenge has the potential to really make a significant difference and to advance the technologies that support our quality of life, but to really make it even better, enhance our quality of life. Now, I personally place a tremendous value on helping to support startup community, startup technologies, and the importance of technology innovation. I co-founded a company some 30 years ago, and I still cherish the excitement of developing the technologies and then seeing the marketplace show interest in that technology and then providing it to the marketplace and the value that your hard work is providing. And I really encourage each of you to not only continue to refine and make the best innovation you possibly can, but to also enjoy the time that you're doing so. Now, this is the second year that EPRI's Innovation, our Incubatenergy network, has hosted the Incubatenergy Lab Challenge, where we're really bringing together a variety of parties, from utilities to you, the startups, investors, incubators, and accelerators, to learn from each other and to help accelerate the ideas to full market potential. So this effort so far has been, I think, enormously successful, thanks to the hard work of you and everyone involved. And working together, we can really bridge the gap between the startups and the utility needs. We can help identify and unique additional innovations that are needed by the industry and help to encourage the startups to continue to optimize the ideas that they have, that you have, to really make sure we solve a unique need in the industry. And so now I'd like to turn it over to the innovation leads from our host utilities to say a few words about the power of innovation. So be safe, healthy, and enjoy Incubate Energy Demo Day. I really appreciate you being here and look forward to talking to you in more detail later. Thank you.
Technology innovation will be key to achieve a low-carbon future, to achieve an energy system that will be resilient, but also reliable and affordable. Many of these innovations will come from startup companies.
In 2019, AEP joined with EPRI on the Illumination Lab Accelerator to create what has become today's Incubatenergy Labs, because we see the benefits of engaging with the startup community. We know that the best ideas and solutions don't always come from within AEP. AEP is scouting in a number of focus areas and uses interactions with startups like those in Incubatenergy to rapidly test their ideas and see the impacts to our business.
One of our first utility customers in 2019 was AEP as part of their Illumination Lab program with EPRI. To date, for our clients, we've assessed EV feasibility for more than 70,000 vehicles, 3.5 million trips, and 350 million miles of data.
You know, innovation is critical, not just to Ameren, but to our industry, as we look to design and deliver solutions that drive customer value in the future. And interacting with startups is a really important part of that. We have a variety of ways that we develop our relationships and pursue innovation, but what startups do is give us a view from an entrepreneurial point of view as to how our business is changing. And that is a really important aspect of preparing for the future.
Last year, we conducted a project together with EPRI and Salt River Project. We identified where our solution can really help utilities and how we had to trim our vegetation risk parameters. This really helped us to bring our solution to even more utilities in North America and Europe. We are currently in the process to rolling this solution out to thousands of overhead miles, and we will be the first company to provide multiple utilities on an entire network basis with this solution.
Innovation and startup engagement is very important to TVA. The world is changing at a very rapid pace. How utilities supply energy and how consumers and businesses use it is all part of the incredibly fast change. For the utility industry to meet those changes, it is critical that we leverage all the potential ideas and resources so we can meet the needs of these quickly changing times.
We are continuing to see great interest in this space, a lot of different investing going on, and particularly in the key areas that our utility partners are interested in, such as electrification, intelligent operations and digitization, mobility, distributed generation, cyber, and the whole customer experience, whether it be residential, commercial, or industrial, and how that experience is going to be changed and shaped with all of these new technologies.
TVA looks forward to participating in Incubatenergy Labs in 2021, experiencing emerging technology and applications, and collaborating in demonstration projects that can advance our knowledge and ability to serve the Valley. Incubatenergy Labs is one of the best tools to leverage near commercial ideas to speed the changes needed in our industry and at TVA.
Ameren is going to be a host again in 2021, and I'll tell you why. I think this year has shown us the value of collaborating with EPRI and other utilities as we do these startup projects. It's allowed us to leverage our resources with those of other companies and EPRI to deliver even more results than we've been able to in the past.
And we'll have to continue to focus on how to transition to a low to no carbon future, how to transition to a more resilient energy future. This gives you a wonderful opportunity to you. Being part of the Incubatenergy Lab in 2021 gives you the opportunity to reduce your cost, gives you the opportunity to leverage resources across the industry and EPRI, gives you the opportunity to speed up innovation, and gives you the opportunity to bring some of these technologies in real life quicker than what you may have been able to do just on your own. That's the power of collaboration that Incubatenergy Lab provides.
Well said, Arshad, and big shout out to Warner and Mike. What great opening comments for us. So grateful for your support and for your engagement, your leadership. Mike, I have to say that your personal story of entrepreneurship was really particularly meaningful to me, so thank you for sharing that. Also, thanks to my partners in this collaboration across the utilities, AEP, TVA, everyone who's participated. It's the utilities and the investor groups that make Incubatenergy Labs possible. But now it's time to start, celebrating the startups even more. So you did hear from a few of them there: EIQ Mobility, Jan Culp. You do have the opportunity, out in the platform to connect with Incubatenergy Labs startup alumni. It's in the Startup Expo part of the Demo Day platform. So I really encourage you to go out there and see their material and engage with them during the program here today. And so I think at that point, it's back over to you, Eric.
Yeah, Steve, so quick shameless plug. Our production team has asked for a plug of the Chrome browser. If any of you are having issues with your video or chat, you might try switching over to Chrome browser. So back to the program. For those of you that are unaware, Incubatenergy Lab starts with the innovation needs of our utilities and then seeks market-ready innovations from startups for paid demonstrations. For 2020, we had 249 startups begin this process of engaging the group of utilities last winter. Over the spring, we narrowed that group down to the 10 that we ran demonstrations with, and you'll hear from today. As you know, we had a bit of a winter surprise. Facing COVID, we shifted our program to fully virtual for 2020, and we asked all the utilities and startups to reimagine their demonstrations to allow for our new shelter-in-place reality at that time. Each team you'll hear from is made up of the utility lead, in this case, in the slide you see here, Jordan Beach from Ameren, an EPRI subject matter expert, Jamie Dunkley in this case, as well as the startup, Joseph Alone leads EV Energy. Each of these individuals is in a different location around the country. We have 10 of these going on, so to avoid all the connection issues that come with these remote sessions, we've spent the last week pre-recording these sessions. So what you'll see are actually pre-recorded sessions. Steve?
Steve's on mute. I did it again. Okay, so you can see the only random variables you have are Eric and Steve, and especially Steve. So But yeah, so all the participants actually are online live. So if you have questions or you're interested in following up with any of them during the day, you can reach out to them via the chat function. And you can use the meetings tab on the left nav bar to set live meetings with them for later today or in the coming days. So really encourage you to do that. That's really what Demo Day is about, is to connect with these startups, with their ideas, with their technologies, and to think about investment in projects. So please do that when you get a chance. And now let's get started. So first up is EV Energy, one of the projects that Ameren hosted this year. EV Energy is a wireless platform that optimizes electric vehicle charging to save customers money, fully utilize renewable energy, and deliver flexibility services to the grid. Our EPRI expert on this project team was Jamie Dunkley. So Jamie, let's hear about the company and the project.
Hi, I'm Jamie Dunkley, and I'm a technical leader at the Electric Power Research Institute. And I'm here to talk about a pilot project we did with EV Energy. From my perspective, I work a lot on understanding where, when, and how much people charge. There is a lot of activity in the electric vehicle space. Adoption is increasing over time, and we're going to have about 130 new EV models out by 2023. So understanding how much people charge and when they charge is really important to be able to support them from a grid perspective. Currently in the market, there are ways to try to track and gather data on EV drivers, but they are expensive and they often need a physical device that you have to put in the car, which can be hard to do. We were interested in working with EV Energy because they've come up with a solution that is remote. So they gather data from the vehicle remotely, which makes it more scalable and more cost effective. So this was a perfect opportunity to test that technology on a small number of drivers with Ameren and see how it worked. So I'll pass it on to Joe to talk about how the experiment went.
Thanks, Jamie. And I'm Joseph Alone. I head up North America at EV Energy. And as Jamie said, we wanted to test our wireless solution to manage EV charging with some Ameren customers. And so what we did was we deployed our software to 40 Tesla drivers across Missouri and Illinois. And what we did was we took advantage of the vehicle's telematic connection to connect to our platform, which gave us both number one, tracking data on the battery level, as well as the charging that was delivered to the vehicle, but also importantly, the ability to stop and start charging in line with optimized EV charging schedules. And so we actually divided about 40 Teslas into 4 different treatment groups because Ameren was interested in testing 4 different kinds of variables to manage EV charging. The first one had their charging optimized around Ameren Missouri's time of day rate. So what we looked to do here was instead of the vehicle charging as soon as the driver plugged in, whenever that was, we would try to sort of shift the charging to the off-peak window in Ameren's time of day rate to save the driver money. We had a second group who had their charging optimized to Ameren's hourly pricing. So in Illinois, Ameren has got Power Smart pricing. It's a dynamic hourly rate that tracks the day ahead price curve. And we, again, tried to optimize EV drivers' charging to really charge during the lowest priced hours while still getting their vehicle ready by the time that they needed it as they entered it in the EV Energy app. A third group had their charging optimized to carbon emissions. So we actually got a generation forecast and real-time generation data across the MISO region. And we used that to calculate the relative carbon intensity per kilowatt hour of a unit of electricity. What we tried to do for this treatment group was to align as much EV charging as possible with a low carbon or renewable generation. Now in MISO, there's not a whole lot of renewable generation that's come online yet. However, that is set to change. Ameren's recently announced a very ambitious net zero pilot and a whole lot of renewable energy that's going to be coming online. So what Ameren wanted to test was how we can actually use the EV flexibility to soak up a lot of that renewable generation when it does come online. And the last treatment group had their charging optimized to some network signals that we got from Ameren's distributed technologies team. The idea here was to see how we could either shift or curtail EV loads in line with dynamic network signals that we'd be getting to avoid network stress and thermal constraint events. Now I'm going to hand it over to Ameren to discuss a bit more about how the pilot went.
Hi, my name is Danielle Wilson, and I'm an innovation manager with Ameren. And we as a company are focused a lot on electrification as a whole, and specifically EV adoption. However, we know that with an uptick in EV adoption, it can come with a lot of unintended consequences and pose several challenges like grid reliability and a reliance on high carbon sources of energy. So that's why we decided to partner with Incubatenergy in order to explore how their app and the use of the telematics can be used to optimize EV charging for things like schedules and loads in order to address these challenges that are coming down the pike. How do we do things like partner the excess solar from our O'Fallon Solar Energy Center with an uptick of demand on the grid? And we felt that Incubatenergy had a great remote solution for doing so. So we also wanted to make sure we pass those solutions directly on to our customers in the form of savings, in the form of carbon offsets, and in other things that we can pass along to our Ameren customers. So we're excited to see what pilot project in order to continue to deliver benefits to the reliability of our grid, to our customers' wallets, and to continue to deliver greener, smarter, and cheaper sources of EV charging.
So what we found interesting in this project was to see that the final data did show how shifting charging sessions to overnight can benefit the EV customer, the utility, and the environment by reducing CO2. I'll hand it back to Joe to go more in detail on that.
Thanks, Jordan. Yeah, I think in general, we saw really positive results from the pilot. For those who had their charging optimized to the retail rate, we saw savings of up to $11 per month for those on the time of day rate. So that's pretty significant savings on a monthly basis. As Jordan said, we also were able to get about 85% of charging aligned to the lowest carbon hours on the MISO grid, and that reduced CO2 emissions by an average of 112 pounds per EV per month, which annualized over an entire year is about the equivalent of a round-trip flight between New York and London. And on the grid intensity as well, we were able to curtail quite a bit of charging during a number of thermal constraint events that we simulated. And of course, I think a next step there is to actually deploy this at a larger scale in Ameren's grid, potentially get it integrated into Ameren's DERMS platform, and actually really sort of test out then the real value that load curtailment and load shifting can deliver from a network perspective as a non-wires alternative to managing grid congestion. Beyond that, we also saw quite a lot of engagement with rewards for participating in managed charging. So one thing that Incubatenergy is working on is actually expanding our rewards program. In our app, drivers earn rewards for allowing the utility to manage their charging. And we've done it through sort of a gamification approach where drivers earn points for every eligible charging session. So we're looking to sort of expand that out and also offer new rewards. One reward in this pilot that proved very popular actually was carbon offsets. A lot of EV drivers understood that there was some carbon coming from the grid associated with the electricity they were consuming, and actually elected to get carbon offsets to offset any additional electricity, any additional carbon that was associated with their electricity consumption. So we're working on building that out. And then, of course, we're also interested in rolling this out across Ameren, Missouri and Illinois to customers to get them saving money. And of course, we're always interested in talking to other IOUs and munis who are interested in testing the solution in their territory. Thank you so much for joining us. We would love to see you at our virtual booth. And if you want to sign up for a 15-minute one-on-one, please go ahead and do that. You can also check us out on our website at http://ev.energy.
Thank you, Joe, and the whole EV Energy team. I am really excited about that project and the potential it has for delivering managed charging that really helps customers customize their charging to the outcomes they are looking for at a low cost. So as we think about efficient electrification and trying to encourage the adoption of electric vehicles, it seems like this technology might have some real legs, Eric. So really excited to see what comes next on this one. So what's up next?
So yeah, next up is Gridfruit. So Southern California Edison led the project with Gridfruit. Gridfruit manages commercial refrigeration fleets to provide cost savings for convenience and grocery stores, has the potential for significant load shift capabilities for utilities during peak hours. So please welcome Annie Haas, my co-lead on Incubatenergy Labs, to kick off the Gridfruit project discussion. Over to Annie.
Hi, everybody. I'm Annie Haas. I am the program co-lead for Incubatenergy Labs, and it's my pleasure to introduce to you today Team Gridfruit. We'll get right to it, and I'd like to turn the mic over to Jesse Thornburg. And Jesse, tell us who you are, about Gridfruit, and what it is you do.
Thanks, Annie. I'm Jesse Thornburg, co-founder of Gridfruit. We're really excited to be partnering with Southern California Edison and EPRI for Incubatenergy Labs 2020. My team formed Gridfruit from energy technology we developed at MIT and Carnegie Mellon University. We reduce energy bills for food businesses by optimizing how their refrigeration runs. We do this by building digital twins of the food businesses, and then we use artificial intelligence with refrigeration data so our software learns and accommodates the needs of each food business. This in turn helps the grid by reducing peak demand and greenhouse gas emissions.
Excellent. Thank you so much, Jesse. Appreciate that. We're going to pivot next to Edwin Hornquist. And Edwin, you want to introduce yourself, please, and talk about why this project, why Gridfruit, and why it's important to you at SCE.
My name is Edwin Hornquist. I'm with Southern California Edison. I oversee the Emerging Technologies program at Edison and statewide. The fundamental reason why we were attracted to this project initially, or this technology, was the fact that we was focusing on an important area for the utility, the area where we are trying to manage our evening peak. We're trying to manage our 4 to 9 peak, but also we want to do it smartly by providing benefits to our customers. And the question was, the fundamental question that Gridfruit brought to us was, we can do this and we can do it with no impact to the customer and bringing value to both to you and to the customer. And not only that, we're focusing on convenience stores initially as part of this pilot demonstration that essentially reduces the risk for us on subsequent phases of this project. And by focusing on an underserved market, we felt that addressing also program needs. So not only it presented an opportunity for this markets that have been underserved for many years, but also the potential for a growth beyond its current application. Thank you.
Thanks so much, Edwin. So we'll turn it over to Ami Amarnath from EPRI now. So Ami, can you introduce yourself and then talk a little bit about what we did in this demonstration and what the results were?
Thank you, Annie. Again, my name is Ami Amarnath. I'm a senior technical executive in the customer solutions group at EPRI. I manage energy efficiency, demand response, and related areas of research. So this whole idea, like Edwin mentioned, is the reduction of peak demand. And one of the underserved markets is convenience stores, stores like 7-Eleven. So the whole idea is to use this artificial intelligence platform and modeling technology that Jesse and his team has developed at Gridfruit, and explore this possibility of testing it in several stores in Southern California and in California in general. Because of COVID, we went forward with doing a simulation of this whole area using their artificial intelligence platform. And like Edwin mentioned, there were three areas, that is of importance. One is reduction in bills for the customer, which is one of the most important area. Second is peak reduction for the utility. And thirdly, related to greenhouse gas reduction. The modeling exercise that we did showed that for the whole state of California, there are over 12,000 of these small convenience stores. We can see approximately 7.5% reduction in bill savings for the customers, approximately 4.5% of peak reduction, and 4.7% of greenhouse gas reduction. So this is a wonderful exercise. For Southern California Edison service territory, the results are more or less similar, and this is what the results of the project were. Thank you, Annie.
Excellent, Ami. Thank you so much. I'd like to shift it back to Edwin. Edwin, so what do these results mean for Southern California Edison, and what's next?
Yeah, so as Ami mentioned, the potential is pretty large in focusing on an underserved part of our customer base. The savings are real. Savings are potentially scalable to other similar end uses and that have refrigeration type equipment, which is very exciting. So this alone represents already a pretty interesting opportunity, very impactful opportunity once at scale, and it does deliver savings to the consumer. So what we want to see next is really validating these outcomes in a way in situ through some sort of a field demonstration. And the idea is that by doing this, we'll be able to really understand any other barriers that potentially could crop up in the course of implementing these solutions. There is a roadmap that Jesse may talk about a little bit later, perhaps, but it talks about how some of these less challenging and easier implementation pathways are, but we're excited about that we were able to validate with fairly good degree of certainty where the opportunities are and bring value this way. And we're excited for Gridfruit and partnering with them and continuing to understand this potential solution better.
Edwin. Jesse, could you talk a little bit more about what this means for Gridfruit?
Definitely. Yeah, through this project, we were able to show the benefits we provide at a new scale. As Ami mentioned, that's basically looking at effects in the convenience stores across SoCal Edison and across the whole state of California. And the reductions he mentioned translate to $13.5 million in annual savings for Edison's convenience stores and $24 million in annual savings across California. So we have been actually expanding on those results in the digital twins. Now we're modeling larger stores to even throw that into the aggregation and look at the results, partnering the control in larger stores with the convenience stores. Thankfully, Edwin and his team are introducing us to food stores for that in situ field testing. And we're also in advanced talks with several utilities in the Southeast who are interested in these results and the demand reduction and emissions reductions that we're demonstrating for Southern California Edison.
Great, thank you. Ami, in 30 seconds, what do these results mean for EPRI and what's next?
I think, thank you, Amy. I think Edwin and Jesse have expanded on this. And essentially, it's really to validate the technology in doing some real live testing in convenience stores. That's item number one. Expanding it around the country, doing a collaborative test with a bunch of other utilities. And finally, expanding it beyond just the peak reduction in the defrost cycles, perhaps looking at the HVAC loads optimization and things of that nature. So this is a very exciting project, and we are excited to move forward.
Awesome. Cool project. So as you heard from Ami, you heard from Edwin, COVID forced us to reimagine this project as more of a modeling effort than an actual field demonstration. We're really looking forward to seeing the results that the connections that SoCal Edison is now helping Jesse with to deploy this in convenience stores across the Southern California territory and see what kind of results that we get in that place. So just another quick reminder, as you're listening to these presentations, include your questions on chat and reach out to these companies via the meetings tab on your left nav bar.
Yeah, it's a great reminder, Eric. Thanks for that. Those virtual conversations and collisions are really what Demo Day is all about. So get out there and engage. So now on to our next company, IND Technology. IND's remote sensing and analytics technology detects and locates electrical faults before they occur, which could help prevent power outages, detect wildfires, and provide early awareness of other threats to system reliability. Ameren hosted this project as well, and our lead was my lifelong friend and coworker, almost lifelong. We've both been at Ameren more than 30 years, I think. So anyway, Jeff Hackman. So Jeff, tell us about this cool technology and our project.
Good afternoon, everybody. I'm Jeff Hackman. I'm with Ameren Company out of the St. Louis area. I'm the Senior Director of Business Development and Special Projects. And before that, I had involvement in transmission operations. With me today, I have Andrew Walsh from IND Technology and Joe Potvin from EPRI. And we hope to share the exciting news that we've had with this pilot project. When we had Pilot Day, we saw a number of interesting companies present and pitch their products. And I got to tell you, when I saw this one from IND first came up, I said, this is it. I don't care what else I've seen that I like better. Nothing is better than this one. The idea that you could identify problems on your transmission system that were soon to come, event anticipators, if you will, seemed really, really important. There are three main things immediately that rushed into my head when I was thinking about this. First is the obvious one, which is customer impact and eliminating outages that might be coming. The second thing that jumped into my head was, this would allow us to efficiently group our work, right? I mean, one of the big challenges in customer affordability, which affects our industry, is making sure that we're as efficient as possible, and the idea that you always have to run out and repair things when they happen is not as efficient as it could be. And so if you can bundle the work. And the third thing is near and dear to my heart in the transmission space, is the risk elimination and mitigation, right? I mean, if you can identify that a conductor is going to have problems in the future, then you can get out and stop it from happening. I was really excited a couple of years ago when we got these relays that could clear transmission circuits before they hit the ground. But even better than that is being able to identify that they're going to hit the ground in a couple of days. And so it was just a really, really exciting time. So what we hope to get out of is a little experience with IND Tech. I can only tell you that the tech is magic, but I'd turn it over to Andrew Walsh to tell you how it really works.
Yeah, thanks, Jeff. So the EFD system, or early fault detection system, is based on radio frequency data collection. And we do this by a series of installations which we put along a transmission circuit at 3 to 5 miles. Historically, we've worked mainly in the distribution circuit space, and that's been our experience in the west coast of North America. The sensors are wireless. They look at the line. They're fed down to a control unit, which is essentially a computer on the pole or the tower, recording the signals it sees that travel along the line. Those signals are transmitted via broadband or 3G, 4G to a cloud infrastructure. From there, the data is transmitted to a visual overlay, and with over the top of a Google map, where it gives the end user rich visualizations, so they're able to look at what's happening on their network every second of every day. What's unique about the technology itself is it's able to locate issues, as Jeff said, emerging issues down to 30 feet. So gone are the days of saying, hey, there's a fault out there, it's down the line. This is now go to this specific point on your line and look for an emerging issue, which will play out in, as Jeff said, the days or months to come. Joe, I'll hand it over to you for your thoughts.
All right, great. Thanks a lot, Andrew. So the approach to examining the technology was first to identify some circuits where we thought it could really show its stuff. So Ameren identified a few different transmission and distribution circuits where there were known issues. The sensors were deployed on those circuits, and the idea was basically to see what sort of information comes back, and if it marries up with different events that or outages that may occur. Did they see them coming? Does it marry up with different defects that perhaps weren't caught with visual inspection? So really the idea was to deploy the system and see what's it seeing that isn't being seen during a traditional inspection. Beyond that, once those signals start rolling in, then the idea is to identify where they're coming from, take a closer look at the asset, and then if able, remove it from service and try to determine what's actually wrong with it. And the reason for that is to get a good idea of, is this something that needs to be repaired right away, or is this something that could have waited for some time? So part of the technical approach is just understanding what is data that we can use to inform maintenance and repair actions now versus what can wait for a while, and how do those signals manifest themselves?
Thanks, Joe. And as Joe mentioned, one of the reasons we were interested also was that when IND was pitching their product at Pilot Day, the primary use case for them had been distribution so far, and we wanted to validate that that it would work well on transmission and subtransmission as well. The technology rose to the occasion, that's for sure. We knew we had trouble on the circuits, the transmission circuits that we put them on. That's why we put them on. We didn't know where the trouble was occurring, though, and so we've been able to focus in very closely. In fact, in one case, IND was hedging their bets a little bit. I don't mean that in a bad way, but in a good way. They were saying, we're pretty sure it's at this structure, but it might be plus or minus 50 feet. So we had a drone go up and do a very detailed inspection. But when we got done looking at the 50 feet plus or minus, it was right on the structure, just like they called it out. And I have every reason to believe that if it had been on further mid-span, that they would have identified it too. We've not only validated that you can use them on transmission, but the other thing that we really found out was that it really didn't matter what the configuration was or the structure type, the material, or whatever. The technology is kind of oblivious to all that stuff. I mean, you can apply it anywhere. We purposely picked hard ones where like on the subtransmission circuit where it changed configurations throughout, and from deltas to flats to verticals, and we were able to mount the sensors within the requirements of the specifications, which really are not very much, which is just make sure that they're the same distance from the phases, which makes a lot of sense if you think about the principle behind it. And so what we really found was that the thing is extremely adaptable. It works everywhere on our system, and we're excited as heck that we found these locations right off the bat. We didn't have to wait for weeks or months. We didn't have to wait for them to materialize into something bigger and broader. We were able to get to them now, and in the one case, we feel like we've got some severe corrosion on the insulator. I doubt when we take it down, which we will, because we want to send it to EPRI so they can do some testing. But I doubt that we'll find it was in imminent danger right now or within the next year or so. But the fact is that when we know it's there and it's likely to occur, and we know how the risk pattern goes, we're able to exactly identify when that's occurring, in addition to all the other things that it finds, where even if vegetation tends to approach and not even within the strike distance, as long as it gets into the plane, IND will pick it up. It's really remarkable that way.
Wow, some very encouraging early results, I have to say. So I've known Jeff Hackman for a long time. Jeff is not easily impressed, okay? I just have to say that. And for him to be as excited as he is about this technology, I think it has a really bright future. Could really be a game changer for utilities' situational awareness on their T&D systems. It's a really great work team. I really look forward to seeing more of the results and seeing where we take this in the future. So Eric, back to you.
Yeah, I agree with you. I agree with Jeff. It's magic. And the one of the amazing things is IND technology from Australia is detecting things like this that are going on in the middle of the U.S. So yeah, just an amazing project. Really excited by it. So next up is Cognitive Spark, a little shift to our workforce. So utilities are constantly looking for solutions to support their workforce. EPRI's Mac Buck led this project with Cognitive Spark to test their augmented reality solution that promises to help increase the efficiency, the safety of field workers, and help facilitate rapid knowledge transfer as new workers are onboarded. So we'll shift over to Matt to tell us about the project with Cognitive.
When I first got involved with this Incubatenergy project, it was very interesting to me in that I've got a plant background, so looking at ways to help the field workers actually visualize the work they're going to do, and also to have support on demand was really very interesting. Now, due to some of the travel restrictions with COVID, when we started this project, we decided to host it within EPRI. And we've got a fantastic high voltage test lab up in Lenox, Massachusetts, where we decided to do this project. So as we worked with Cognitive Spark and with the guys at the Lenox lab, really the project came together a lot better than we ever could have imagined it would. So as just a review or a summary of what it is, Cognitive Spark has developed a platform to utilize the Microsoft HoloLens 2 for remote subject matter expert support. Now, what that simply means is that the field worker can place the HoloLens 2 on their head, be immediately connected with a subject matter expert at a different location. That could either be in the control room or in the office space of the same plant, or even in maybe an engineering headquarters hundreds of miles away. Now, the other interesting facet about this project is the fact that they could build holographic models and transmit those to the field worker to review before they actually start the task. Just to tell you a little bit about the technology and how it works, I'm going to turn it over to Duncan McSporran for a few minutes to tell us about Remote Spark and what got them interested in this involvement with EPRI and Incubatenergy.
Great. Thank you very much for the introduction, Buck. My name is Duncan McSporran. I'm the Chief Operations Officer for Cognitive Spark. We're a Canadian-based software company that is really identified as a leader in secure and reliable applications for the use of mixed reality for remote worker support. Our flagship product has been the core of this project, and that's called Remote Spark. And this is an industrial-grade solution built for the Microsoft HoloLens and other platforms that digitally connects remote workers to subject matter experts so that they can facilitate complex troubleshooting and task guidance in a way that's not been previously possible. We're partners with Microsoft and with HPE, amongst others, and Microsoft have identified the fact that in this particular field, we're a global leading competency. And we actually have capabilities which are network agnostic. So what you're able to do is operate this capability that we've created either on cloud or on premise, so completely disconnected from the internet or any external connectivity. And it's designed to help industrial organizations to reduce travel costs, facilitate knowledge transfer as our experts get older and get close to retirement, so that we can get that information to the people that really need to know, which is that next generation of technicians and workers, and to reduce equipment downtime while supporting workforces remotely. And what we also hope to do really with the introduction of this type of technology, not just ours, is also to reduce the number of errors and the amount of errors, and reduce the amount of time that equipment is offline because somebody has made the wrong decision because they think they're doing the right thing, but they're not doing the right thing. As I mentioned, we're based in Canada, in New Brunswick in Canada, and we set the company up in essence as a security company to create mixed reality solutions. And that's led us through a very rocky road as far as the development's concerned in terms of the challenges that we faced. But what it's led us to is an incredibly stable platform that is able to work on very low bandwidth with very high security. And that's really important from an industrial perspective. And our focus, whilst we're a security company at heart, making these solutions, our focus is on making mixed reality work where the end user needs it to work. And we'll hear some comments from Mike in a short while about his thoughts on this as he's tried this system at the Lennox lab in Massachusetts. But really what we've done here and what we've managed to be able to do with the Incubatenergy program and with Matt and with Lennox Lab is to do what we do with all of our deployments. We build partnerships. This isn't about a company which comes in and sells a software solution and walks away and comes back in 12 months for a license renewal. This is about building the solutions to help that end user do their work as effectively as they possibly can using the most modern technologies in a really stable and applicable way. And right from the word go, what we've seen here within the EPRI project and within the Incubatenergy project is a whole host of end use cases where this will have a direct impact on the operations of utilities as we move forwards. Now, we've done this in a cloud-based solution, and that was because of the situation we found ourselves in with COVID-19. It was easier for us to facilitate the test and the trials using on cloud because it meant we could do what Remote Spark says it can do on the package, which is help people work remotely. And we've done that without the need to travel. I've not been to Lennox. I've not been to where Buck is now in Florida. And we've not been to any of the other EPRI sites. We've done this all through remote working principles. But equally, where there is a requirement, and that may be within certain parts of the utility sector and the power generation sector, there may be a requirement to do this on-prem, and we're able to do what you see here in this report and what you see through the videos equally as well on-premise as we can do using the cloud. With that, I am going to hand over to, I'm going to hand back to Matt, and we'll hear from Mike in due course as well. Thank you very much.
All right, thank you, Duncan. As we started off this project, of course, we had to capture some images to build the models of some of the equipment at Lennox, and we talked about a few different things and ended up with the using an SF6 breaker and also an SEL 751 relay. And Mike was involved from the beginning with capturing photographs and helping us build the models and then execution. So Mike, just a couple of thoughts from you as far as from the field perspective, the process of working with them to build the models and then actually executing processes for the demonstration.
Okay, thanks. So I was basically given a set of goggles and an email and told, here you go. And the process was actually quite easy. I spent about half an hour to an hour just learning the basics of the goggles, which are pretty mind-blowing. And then I just took some photographs from my phone and uploaded them to Buck, who provided them to Cognitive Spark. And I don't know, within a few days probably, they provided an amazing 3D model of the breaker and the relay. Details were outstanding.
and it was then uploaded into the goggles where you could then have some bit of interaction with it, spin it around, play any animations that there may have been on there, which was incredibly handy because I wasn't very familiar with either of those pieces of equipment, which I think is probably the benefit of the goggles, is you can have someone with relatively zero experience have information on your screen, on hand, and also have an expert in the background just seeing what you're seeing and telling you, you know, don't touch that. They actually have the ability to draw on the screen so you can see what they've drawn or highlighted in your field of view, regardless of which way you turn your head. Absolutely amazing. And it's pretty obvious that, especially in this time of limited travel, how the potential of this software and these goggles, especially for us in Lennox, where we are a relatively small group of people in a relatively large environment, and many of our experts are throughout the world. And without having them come here to be on hand, the next best thing is actually having them essentially in your head as you're seeing and interacting with them, and the whole time you're hands-free, and it's just a wonderful technique.
So, you know, from the beginning of the project through the closeout, it's been very interesting, and I believe there's a lot of potential for field workers using this technology. Now, obviously, anybody that's used the HoloLens understands there are some limitations to that technology. We still need to address the adaptation with a hard hat for use in PPE required areas. But the second generation HoloLens is much improved over the first, and I'm very interested to see where we go next steps. We've already had a couple of utilities reach out with interest in doing on-site demonstrations. So I'm excited about it, and I think it's going to be valuable as we move through and for the future of the digital worker.
Thanks, Matt and Duncan and Mike. Great project. Just like last year's REO project that was led by AEP was an AR/VR technology. This is one that, as Matt mentioned at the end, there's got a lot of interest across the group of utilities. So really excited to see where this comes, because really a game changer for facilitating efficiency, but also safety of our field workers. So really cool solution. Next up is Line Vision. Line Vision is a startup that provides insights on line health and dynamic line rating capabilities for transmission lines. This project was led by TVA. So James Linder at TVA is going to kick us off to talk about the project with Line Vision and explore the line health capabilities of that solution.
I'm James Linder, Innovation Scout for TVA, for our Transformative Innovation Group. This is TVA's second year with Incubatenergy Labs. This year, we chose to host Line Vision as our partner to identify new innovative ways on how TVA is approaching the transmission system by using emerging technologies to enhance the grid. Line Vision deployed a non-contact sensor to deliver situational awareness for the lines and collected data that they used to build comprehensive line health report for each line. No outages or live line work was needed to install Line Vision's non-contact sensor technology. The sensors were mounted on the transmission structures themselves. All 3 sites completed in 2 days of field work. TVA selected spans on 3 different circuits, 3 project sites, where conductor health was a concern. We chose these lines from engineering perspectives based on, 1, various voltage levels, so that these were from 500 kV to 161 kV, different conductor types, bundling, single, double, triple, or bundled, lines with and without mutual inductance from other parallel lines. Also, lines located on TVA property to minimize the impact on landowners based on the time and scope of the demonstration. Currently, TVA does not have a standard testing when failures happen on lines. Non-contact sensors fit the 4 of 7 pillars of grid modernization that TVA has. The first one is data analytics. Data-driven decision for operations. Treat data as an asset. Our next one is the field technology. Enable our transmission and field crews with new technology to make their jobs safer and more efficient and automated. The next one is grid visibility. Increasing real-time visibility and control for enhanced situational awareness and improved decision-making. And our last one is our asset management performance. Maintaining a safe, reliable system to ensure assets are operating at the desired limits and meeting the system performance. So now I'm going to kick it over to Alex from Line Vision to tell us about the technology.
Thanks very much, James. It's been great working with you and really proud to have been your second project as part of Incubatenergy. As James mentioned, our partnership with TVA was to explore Line Vision's line health application, which tracks changes in conductor health over time. So our combined platform ingests both historic line data and real-time data using a scanning optical sensor with LiDAR to monitor your lines and report on damage from annealing, the effects of extreme weather, and elongation. And we use that information to generate reports for safe operating limits and the projected end of life of your conductors. And really, until now, utilities have needed to rely upon assumptions or destructive methods to understand the health of their lines. But Line Vision's technology gives you a non-contact, non-invasive way to assess your conductor asset health, just like James mentioned. The results of the reports we deliver are objective. Everything is physics-based and follows IEEE and CGRE standards. So whether we find extensive damage and accelerated end of life, or if everything is looking great and the lines are in good shape, either way, you're going to learn that as an output of our technology. And frankly, it's more important to know if your conductors are in bad shape so you can take steps to correct the problems before they become more expensive or more dangerous. But I guess objectivity aside for a moment, I'm really glad to report that the lines that we monitored for TVA that James mentioned are in really good shape. It's like when you're young and you go to the doctor for a physical, maybe there are a few areas of concern, but overall you're really in good shape, you're healthy. And that's the case with TVA, which was great. So what did we learn from those three sites? First, importantly, we detected no damage from annealing at any of the three sites. Our historic thermal analysis showed no accelerated thermal aging. Our historic thermal analysis is important because that's what's going to point us to the need to look more carefully at existing lines. On one line, we detected under-tensioning compared to the post-creep design, and on another, we detected over-tensioning compared to the post-creep design, but both were well within NESC limits. We did find conductor elongation on one line, with the result that the designed sag limit would be reached at 190 degrees Fahrenheit, which was before the maximum operating temperature of 212 degrees Fahrenheit. So at the maximum operating temperature of 212 degrees Fahrenheit, the sag will equal 27.3 feet, which is 0.9 feet more than the post-creep sag limit of 26.4 feet, which represents an elongation of 3.4%. However, TVA is very careful, and their designed final sag values have a 3-foot safety buffer, and this increase in 0.9 feet still falls well within TVA's 3-foot margin of safety. But it goes the other way too. On one line, we observed that the design sag limit would not be reached at the corresponding maximum operating temperature. Instead, at the maximum operating temperature, the sag would equal 49.9 feet, which was half a foot less than the design sag limit, but safely within compliance. So overall, TVA is doing a great job, but the reality is nobody knows that you're an A student unless you run some tests. And that's why line health as an application is so important. So our goal at Line Vision is to give you the tools to save time by having on-demand information about your conductor's health. We will save you money and resources by giving you the actionable information you need to prioritize maintenance and make business decisions about the management of your assets. We really enjoyed this project, and we very much look forward to meeting with you individually today. So thank you very much. And with that, I'm going to turn it over to Justin Bell, who is with EPRI, and going to talk to you about EPRI's role in this project. Justin.
Thanks, Alex, and thanks, James. So EPRI had a very unique role in this process in that this is really a demonstration project, and typically our role is more in a validation project, but what we did is try and modify what we would normally do for a validation study in this demonstration role. So Line Vision deployed their unique sensors, their non-contact sensors into the field, and EPRI has also deployed precision weather stations to help gain some additional insight as to conditions that are occurring near the lines. And we can show both Line Vision and TVA the methodology by which we would traditionally validate the performance of some of these tools and assure that the accuracy is within the limits that we're striving for. So as we begin and continue to collect data, we're going to be prepared in the future to say more definitively what the performance of some of these systems are and verify the value that TVA is receiving from this technology. One thing that we're seeing, and one thing that Alex has already mentioned, is in some cases there's room for additional capacity on these lines as identified by things like the SAG analysis. And the Line Vision technology allows you to utilize that capacity by giving you some real-time intelligence of the line, which is something that's a growing industry need. And many utilities can relieve congestion and increase throughput or improve their utilization of renewable energy by utilizing a more time variable rating. And that's something that we've been able to bring into these discussions with James and the TVA team. And James, I'd like to turn it back to you for any thoughts and closing comments.
Yeah, thanks, Alex. Thanks, Justin. So, as TVA continues to analyze the data from the line health report from our transmission line engineering design group, I want to give a brief update on about what we have discovered so far through this 12-week demonstration. The asset health report, we learned that this approach would help TVA observe the lines that are deteriorating rather than flying a particular line and giving us a point of time analysis. Using this sensor, we could watch and see how this line was loaded and the effects of weather it has during critical peak times when the system was loaded or over a greater amount of time versus the one point in time. Second, as TVA staff reviewed the line health report, we discovered something else that wasn't part of the scope. Line Vision's capability of calculating and sensing the dynamic line ratings. This is particularly of interest from our operations staff, and we're looking to explore this further with Line Vision in the future. Thank you for your time, and thank you for a great demo day.
Great, and thanks from James, Alex, and Justin on that project. So as you heard from the team, the project is really focused on Line Vision line health reporting features. We're really encouraged by those capabilities. We only have a short time to look at this. We'd really like to look at it over a number of seasons. So we plan to continue running that system through its paces over the coming months to fully characterize the line health aspects. And then as you heard from James, a lot of interest across the group of utilities and across EPRI on the dynamic line rating aspects of the solution. So a lot of things still to explore with Line Vision. Before we move on, just a quick commercial. We've structured this day so you see these presentations from the companies. They're fairly short. We have reserved 15-minute meeting slots available with each one of these companies. So if you are a utility or an investor that is on the phone or on the line here, definitely go over to either the Startup Expo will get you there or the Meetings tab. Set up and reserve one of those 15-minute slots to talk more in depth with any one of these companies. You can also reach out through the Meetings tab to reach out to any of the project leads. So if for this one, for example, if you want to talk to James or you want to talk to Justin, they're online as well. You can reach out through that tool to be able to contact with them.
Great reminder, Eric. Yeah, it's all about these collisions and discussions, so please get out there and do it. Next up is Ping Things, another Ameren-hosted project. Ping Things is an artificial intelligence platform that processes, stores, and uses high-definition sensor data in real time at grid scale. We've got some pretty interesting use cases we're going to talk about here in a minute, but here to introduce the project is EPRI team member Ed Barosit.
My name is Ed Barosit, and I run EPRI's Advanced Metering Systems project set.
Utilities today are gathering unprecedented amounts of information via their advanced metering systems. To be able to take this vast amount of data and turn it into some actionable intelligence is really important. Having a platform by which to do that is vital.
The grid is becoming increasingly complex. Things like distributed energy resources pose new challenges to how we operate our grid. The amount of sensors on the grid is also growing at an amazing rate, with increased deployment of digital fault recorders that measure at an extremely fast 4,500 times per second, to PMUs on our transmission and distribution systems, to information flowing out of our SCADA system, all the way down to AMI meters that are recording at a relatively slow 4 times per hour. This data will allow for an increasingly complex grid to be operated more efficiently and more reliably. To do this, a single platform is needed, which can store all the grid's data, ease data interactions and access, while enabling AI solutions. PingThings has shown success in working with the grid's fastest sensor data, digital fault recorders and PMUs, but we want to test their system with the grid's slowest data, and that's AMI meters that only update once every 15 minutes. We selected a sizable chunk of AMI meter data, though, that came in at over 8 terabytes in an uncompressed state. Testing the PingThings platform with the grid's slowest data would be quite beneficial. It would allow us to see if they still had good performance with this slow sensor data. And if they did, well, their platform is then a single grid analytics solution. But we wanted to do this by tackling real-world problems. And we chose secondary connectivity modeling and customer phase identification, which are both foundational for having an accurate grid model, as well as good customer experience. Solving real-world problems is important. Strawman comparisons and synthetic benchmarks only go so far. To test a tool's performance, you have to build something with that tool. And to tell us more about what we built, I'll kick it over to Ankush, a data scientist at Ameren.
We now look at how we perform the benchmarking of the two platforms. At Ameren, we collected the raw data and handed it off to PingThings. To process this huge data set, we had to set up an EMR cluster on AWS with 8 machines and 64 cores. We developed an algorithm in PySpark to solve the secondary connectivity problem. The algorithm is based on correlations between voltage signatures for every pair of meters. PingThings also refactored our algorithm to run on their platform. So with this, we had 2 same algorithm executed on the same dataset, but on 2 separate platforms. This benchmarking would help Ameren to gain insights on its cloud computing capabilities and also guide us for our future analytics efforts. At Ameren, full-time data scientists worked with interns at the Ameren Innovation Center in Champaign. A loud shout out to one of our interns, Dara Zerlin, who helped us to optimize all our algorithms. Now I will hand it over to Sean, who will continue with the next slides.
Since this project started in June, it's been a pretty wild ride for PingThings. We are a seed stage company and have literally doubled in size in the last few months, adding 8 new full-time software engineers and data scientists. Further, we have 1 new customers, not just in energy, but also oil and gas, transportation, and cable, all of them needing help with time series data at scale. As a result of this growth, we've now entered into our Series A fundraise. Scott did an excellent job of overviewing the project and its importance and objectives. I want to quickly talk about the timing of the work in the PingThings team. We were originally slated to start the project at about the end of May, but due to the types of delays that all data analytics projects tend to run into, we didn't actually get all of the data until August 1st. Since then, we stood up a separate instance of our predictive grid platform. We developed an ingester for the smart meter data, ingested all the data, analyzed its data quality, developed prototype analytics for all 3 algorithms, and optimized one for production, which we'll talk a little bit about later. Not only have we done this along a compressed timeline, we've done so with a very small team. Chris Ryan, shown on the right, really has done all of the work. I've attended meetings, my CTO has helped with infrastructure questions, And Alan really stepped in to help lead our training sessions, but Chris did all the work. And the thing to note is that he was hired during the summer and basically learned to use the platform on the fly as he executed. The platform we've been talking about is the Predictive Grid platform. We built this to make creating value from time series data, from sensor data, easy as possible. Data at rest tends to stay at rest, and the harder it is to explore and analyze and build analytics from your data, the less likely a utility will be to use its own data. Scott has been urging me to make sure that everyone understands the platform's advantages. Not just how we are different from AWS, but how we are different from other analytics platforms. We believe that your sensor data is incredibly valuable and built a platform to help you create value from it. The Predictive Grid platform can handle much larger data volumes into the petabytes of time series. Our platform is both provably faster and faster in benchmarks, often by orders of magnitude. And we built it from the ground up for analytics, not just storage, and we tried to make it as cost effective as possible. The easier we make it to work with your data, the greater the ROI will be for your use cases. Now, we aren't the right fit for everyone, and there are at least a few options or a spectrum of solutions when working with AMI data. There are cloud providers like Amazon that give you all of the individual pieces that you need to build your own solution. Then there are vendors on the other side of the spectrum. There are vendors that provide beautiful but fixed functionality. As Henry Ford said about the Model T, you can have it in any color you want as long as it's black. And then there's PingThings, or I should say Goldilocks. We're in the middle. We're trying to offer flexibility with insane performance so that you can quickly build analytics. On the surface, the two processes that Ameren and PingThings focused in building out a similar set of analytics for smart meter data, they look similar, but there are some very critical differences. First, when you build your own platform with AWS, you face the three-body problem between your users, IT, and AWS. Your analytics groups are the users, your customers. IT assembles the solution in Amazon, and AWS provides the building blocks. Now, IT has now become the vendor providing a product to your team, a product that must be maintained, evolved, and expanded over time based on user feedback. Also, if AWS doesn't have what you need, you're just out of luck. And this actually manifested itself in this project with Apache Spark via EMR. Now, to close things out, we will discuss our benchmarks. This was comparing voltage correlation calculations with 64 substations. On the left is AWS with Elastic MapReduce and S3 as assembled by Ameren. And on the right, the PingThings Predictive Grid platform. So note that the sequence of steps on each side are basically the same. Load data, transform data, then do the calculations. Now, note on the left that it was an 8-machine cluster, each machine with 8 virtual CPUs and 64 gigs of RAM, and it took about 60 to 70 minutes to do the 64 substation correlations. On the right side with the Predictive Grid, we actually computed on the same order of magnitude time in about 35 minutes, but we used far fewer resources, i.e. we were only using a single machine running in a Jupyter notebook, using 8 gigs of RAM, and using 1 to 2 cores of a very old Xeon processor. Please note that we are further validating these benchmark results the rest of this week. Thank you so much.
Thank you, Sean. Ameren's very excited to dive into the details of your team's awesome results. These results are showing that PingThings Predictive Grid is a high-performance solution for all the grid's data. Sean's team and their product have been tested in a new way in this project, and this will help shape their next-generation query engine, guide their enhancement to the visualization system, and it gave them a new perspective on large-scale compute requirements. We'll be wrapping up this project in the coming weeks and finalizing details of an extension of this work. Also, Ameren's going to be reviewing our findings in detail with our cloud team and also our architects to refine our strategy for time series sensor data and analytics.
It's pretty interesting for me to see how utility expertise and data science expertise merge in this project. I am very much looking forward to seeing what happens in the future.
Wow, Eric, I'm really intrigued to see what happens myself as well, like Ed said at the end. Particular shout out to Scott Hickson and my digital co-workers at Ameren for a lot of hard work in a very compressed period of time. I'm really impressed by what this team has accomplished in a very short period of time. You know, robust data acquisition and analytics capabilities at low cost are foundational to making that integrated energy network that we talk about a reality in the future. Next up is Recurve, the fourth project that Ameren hosted this year as part of our support for Incubatenergy Labs. Recurve offers software as a service tools that help customers and utilities deliver energy efficiency results more efficiently and effectively. Matt Golden is Recurve's CEO. Let's hear the story from him and the rest of the Recurve project team.
Recurve works with utilities across the country to help decarbonize the grid and to optimize and make cost-effective energy efficiency and demand response programs. When we started this project, Ameren had an extremely ambitious goal of an 80% reduction in carbon by 2050. But even as we are underway, that goal has jumped from 80% to 100%, with an additional $8 billion invested in renewable energy. This really aggressive goal is going to create major changes to Ameren's supply mix and grid, moving from predominantly coal to a mix of renewables and natural gas. This transition is going to create major changes to Ameren's load shape, new peaks and valleys based on these intermittent resources that stand in the way of decarbonization and are also incredibly costly to Ameren's bottom line. Recurve's goal is to enable behind-the-meter demand flexibility to help solve this problem. This is consistent with Ameren's approach, where you can see that starting with onboarding of increased renewables and eventually retiring coal power plants through that entire span, energy efficiency and demand response is a consistent part of the mix. We help do this by the Recurve platform, which looks at all meters on a utility's grid and provides three primary products. The first, Resource Planner, which is what we deployed in this pilot, looks at all customer meters and helps the utility identify what is the potential for behind-the-meter flexibility and which customers will benefit the most, both on their bottom line to themselves on their bills and to the grid. Fleet Manager enables the utility to track these projects behind meters in real time to create a virtuous cycle of continuous improvement and optimization. The third piece, Flex Ledger, you can think of as the accounting system for flexibility. How do you keep track of all these projects, value them so they can be claimed, integrated into procurement, and third parties can get paid?
Hey, Matt, it was really impressive how quickly you guys were able to turn around the data and the analysis once we were able to move the data over to you. Maybe you can talk to us about the data process and how you are able to do this so quickly for the utilities at such scale.
Thanks, Ram. You correctly identified that ETL, extraction, transformation, and loading of data, is the crux of everything. This is an example of the data flow for Ameren, the steps that we had to go through to take their raw data, clean it, and load it into our platform. Once we got there, we ran a series of data audits to validate that the data we're looking at meets all of the requirements, that there aren't any major anomalies. And we do that internally and also with the client to make sure that we agree that we're dealing with good quality, clean data. And then when we run our actual platform on it, we validate that it meets all of the specific requirements of the Caltrack methods in terms of what is data sufficiency, how do we pick weather stations. All of these important steps have to be followed to ensure consistency of the output. But once we've accomplished all of this, once we have that data flow working and we have a valid method in place, we're a machine. We can automate this process. We can update the data every single night. This is not a one-time exercise, and you can operationalize it in the day-to-day business of the utility.
Thanks, Matt. I think it's important to talk about why we do this. As of August 31st, over 160,000 businesses have closed nationally, and 600,000 jobs have been lost in Illinois due to the pandemic. Nick, your team is working to support Ameren's business customers on a daily basis. What were your goals coming into this project?
We're looking to find those customers that maybe are struggling right now, right? We've got a climate where businesses are having a hard time staying open. You know, we know that a lot of businesses are closing down. And, we understand that customers, while they may benefit from energy efficiency, they don't have a lot of time to be looking for things like this. And we want to help them there. We want to be able to find those customers that are staying open, that are trying to operate. We want to be able to come to them, right? We want to bring them solutions. And we think we can leverage the Recurve tool to come to those customers that are having a hard time, that are busy with other things, and to say specifically, we recognize that you're operating. We recognize that you've got higher operating costs. We think some of these measures that we have to offer could really help you. And we want to ease that. We want to make it as easy as possible for these customers to participate, to take advantage of what we have, and to make their businesses more efficient.
Thanks, Nick. And thank you to your team for all the hard work you're doing to support the small businesses in Illinois. Let's turn it over to Matt to showcase how the Recurve tool can help streamline those efforts and get support to where it's needed most.
I'm going to start with a quick example. This is a set of actual results from a small business HVAC focused program. On the left, we have the load shape of the participating customers peaking midday, and this is what we call resource curve, or when the savings happened over the course of a day for these customers, culminating in about 10 megawatts of savings and about $1,000 in grid value. Now we're going to go through and actually target those using the most summer energy with the fastest ramp rate, the ones using HVAC energy. When we do this, we see a very different set of customers with much better results on their bills and to the grid. We now see a peak of energy consumption during that peak period window that we're looking for, and a substantial overall increase in energy savings. So these customers are now saving 18 megawatt hours instead of 10. That's an 80% improvement. And we've tripled the amount of savings during that system peak window, which doubles the grid value back to Ameren. Now we're going to take everything we've learned about Ameren's small business offering and identify those customers most in need who will benefit most from the program. Beginning with 105,000 total meters on the Ameren grid, we're going to start by identifying those in disadvantaged communities who've seen their energy bills increase during COVID. These are the essential businesses staying open, working every day to serve their communities, who have seen their energy costs increase during this very difficult time. Next, we're going to drill down and specifically look for those customers who will have the greatest effect from Ameren's air conditioning service offering. These customers use substantially greater air conditioning energy, nearly 3 times the average, and will see outsized returns in terms of bill savings and much more cost effectiveness back to Ameren and the Illinois ratepayer.
So Nick, now that your team has had the opportunity to dig into the platform, what are some of your goals and next steps coming out of this project?
There are a few goals at Ameren, Illinois that we're really excited about that we think we can leverage the Recurve tool to meet. We are looking to use the AMI data that we have to have better conversations with our customers. We want to be able to have those specific and targeted conversations with customers, meeting them where they are. We understand that businesses are struggling. They don't have a lot of time to be talking with us to figure things out. We want to be able to have good conversations that can move them forward in the best way that's best for everybody. We want to be able to reduce, by doing that, by having that better conversation, we can reduce the cost of bringing customers in to participate in our programs. We want to reduce the cost of acquisition, which frees up dollars that we can use for more incentives for more customers. We have legislative goals through the state. We're all looking to reduce environmental impact and reduce carbon footprint. And this tool, we think, will allow us to be able to get into targeting those measures that have long lives, long measure lives. We look for cumulative persistent annual savings in the state of Illinois as part of our legislative goals. And we have certain measures that it's hard to fit the customers for some of those measures. And if we can leverage the tool to understand which customers are a best fit, we really think we'll be able to move more customers through those measures specifically that have longer lives and have deeper savings, which is something we're really excited about.
Thanks, Nick. We're so excited that your team has found value with this tool. Ram, I'm curious, where do you see opportunities for other EPRI members?
As we research the future of customer programs at EPRI to meet the target decarbonization targets for the grid and for the economy as a whole, Recurve offers the tantalizing possibility of addressing 2 of the biggest pain points: the cost of customer acquisition and the cost of administering the programs and the measurement and validation. through their database targeting of eligible customers, which also enables pay-for-performance programs and automated M&V. Recurve has the potential to accelerate these customer programs, as well as maybe provide services like settlement functions with the ISO in the future.
Thanks, Ram. And a big thank you to Ameren and EPRI for partnering with us through this project. To everybody in our audience, thank you so much for tuning in. And we'd love to schedule one-on-one time with you either this afternoon or later on if that fits better in your schedule. Take care and enjoy the rest of your day.
Wow, what another great project, really showing the power of collaboration on a very tight time schedule. I just have to give a shout out to Nick and my Ameren, Illinois coworkers. You guys power the quality of life. And Matt, that was a really powerful, just real quick demonstration of how we can use your technology to zero in on those small businesses that are really also powering the quality of life for those underserved communities in Ameren, Illinois service areas. So thank you very much for that. Back to you, Eric. Where are we going next?
Hey, Steve. Yeah, this Recurve one was really cool. Just shows how valuable AMI data can be when you apply analytics and some targeted specific to target specific customers and show them real value out of programs and services. The next one is a really cool project as well. Omar Siddiqui at EPRI leads this fascinating project with RWI Synthetics and the Salt River Project to look at how we can leverage a broad spectrum of research and data to model complex systems and understand how we can better handle multiple disaster events that might occur at the same time.
Pleased to introduce our project with RWI Synthetics. I'm joined by Myrna Bittner, CEO of RWI Synthetics, and Gary Rector, data scientist at SRP. This project was a proof of concept to see how an application of artificial intelligence known as synthetic intelligence could be used to create a dynamic simulation environment in which to measure the impact of a dual disaster in a utility system. We chose an area of metropolitan Phoenix, Tempe in Arizona, and we looked at the impact of a disaster coupled with a pandemic.
So as Omar was mentioning, we tackled an area of Phoenix, Tempe, an SRP service area, and we were able to create a living digital model, so a synthetic twin of this area. And this area included 18,000 households, about 2,000 businesses, and we were really able to apply our modeling technology to bring these things to life. So we first laid down the geospatial kind of accurate physical infrastructure in the area. We were able to do this and synthesize the grid. We were able to apply the consumption patterns that have shifted and changed during COVID. And then we were really able to delve into who is in the area and what might be the impact of this dual disaster. So it was rather a unique project because we were able to model the grid, but then we had to turn the lights out. And this was where some of the really important findings and work was done. So we were able to synthesize the demographics of the area, the psychographics, their forward-looking energy plans, things to do with their health and the disease rate and transmission rate of COVID-19, and really kind of understand the stress levels of the population that might be impacted during this outage and how the outage would affect who needed to be hospitalized and how many, who might be seeking, the really vulnerable populations that might be seeking even backup power during this time for medically assisted breathing. So really be able to delve into every different corner. We looked at businesses and looked at who had access to backup and auxiliary power gained from data around the U.S. in terms of generator sales and surveys from businesses. And then looked at even things like the GHG emission hit during those outages as those businesses' backup power and auxiliary power kicks in. So this was some of the really interesting kind of then what if questions became how to inflect this environment. So the different kind of differences in communications, bad communications versus good communications during a power outage, and how people's forward-looking kind of energy plans may be affected during this scenario, even the trust in their utility company, or how they value reliability. Really, that has changed as a lot of the population is working from home.
It's been our privilege to work with you and your brilliant team and all of the brilliant people at EPRI as well. Originally, SRP wanted to predict our grid resiliency and our disaster response capabilities in the face of multiple simultaneous events. It's a really complicated thing to analyze, if not impossible to do well. We weren't really sure what to do. And so we've had a wonderful time exploring what the synthetic city can do. It cuts through the fog of that complexity. We found that the synthetic city simulation, it connects something like 200 separate models together. And those focus models inform each other to describe individual human behavior, as well as our electric load, the behavior of our assets, civic infrastructure, and much more in the face of those scenarios. So we can observe behavior before, during, and after the event. I think this project has been economical for us, very economical. It's been educational for me. It's extensible. We can use it for much more than we thought. And it's energizing. We're having lots of fun with it. So many thanks again to everyone at RWI Synthetics and at EPRI. It's a privilege to work with all of you.
Thank you, Gary.
Thank you, Gary. So just to wrap up here, this was, as I said at the beginning, intended to be a proof of concept, and that concept was, in our view, very much proven and exceeded our expectations. I think the thing to think about is going forward, this sets the stage for even larger, more extensive applications of this type of synthetic modeling platform, and can be applied to larger real-world environments as a digital twin, with the inclusion of actual local data, both grid data as well as community infrastructure data. And I think the last thing I want to say is that the visualizations that have been afforded through the modeling platform and tools and presentations that the RWI team put together have been outstanding, and I think can serve as effective decision analysis tools to help utility executives and decision makers. So with that, on behalf of the EPRI team that had the privilege of working on this, I want to thank Myrna Bittner and her team at RWI, and Gary Rector at SRP, as well as our other utility advisors for their input throughout this project. Thank you.
So thanks to Omar and Myrna and Gary Rector over at SRP. This was a really fun project. I remember dialing into these calls every week, and in the back of my mind, I'm envisioning Minority Report where they've got their VR gloves and moving things around. It was just amazing to see that they came up with out of this solution. It's one of those projects that really leads people to imagine completely new ways to understand and engage our customers, our complex systems, and so forth. So Myrna and her team are getting a ton of attention. Really excited to see where this solution goes from here.
Absolutely. Really intriguing. You bet, Eric.
Yeah, so next up is Shark Energy Systems. Shark Energy provides a wastewater heat recovery solution. They are out of British Columbia. The solution was one of our most popular, actually leveraged the support of 5 of our utility members in this project. So Doug Lindsay at EPRI led this project with Lynn Muller from Shark Energy. We had great participation from Sylvia over at Con Ed. So I'll kick it over to Doug Lindsay to tell you about Shark Energy System.
Hello everyone, my name is Doug Lindsay from EPRI. I'm here today to talk about our Incubate Energy Challenge project with Shark Energy. Shark Energy proposed a demonstration of their new Piranha HC product. This is a thermal energy heat recovery heat pump, electric heat pump, that is designed to provide hot water and space conditioning at the same time. Our demonstration covered a 60-unit apartment complex up in North Vancouver in Canada, and it was a good demonstration of the product. It's the first demonstration ever that they have undertaken, and we've had some good results from this project. Some of our research questions were just to explore the feasibility of this technology and how it performs in the real world. The goal is to demonstrate that the coefficient of performance can be above 3.5 throughout the year. If you know anything about heat pumps, air source heat pumps often struggle in the wintertime with lower coefficient of performance due to the cold weather. And a ground source heat pump, while also maintaining a fairly constant coefficient of performance, is very expensive because you have to drill holes into the ground to capture the heat from the earth. So this product from Shark Energy is recapturing the hot water that we pour down our drains, and it's a really innovative concept that I'll let Lynn talk about here in a minute. But some of our research questions were to look at the coefficient of performance, but think also about the sizing of this product and what are some other applications that it could potentially be installed in. So I'll turn it over to Lynn here now to talk about the product in more detail and to give you a better demonstration of what we actually did.
Thanks very much, Doug. Lynn Mueller here from Shark Energy in Vancouver. We were extremely privileged to be part of the EPRI Incubatenergy lab tests for 2020. We retrofitted our Piranha HC T10 unit into the 735 building in North Vancouver, British Columbia. It's approximately 60 units of family living, so they have all the normal uses of hot water, laundry. Most of them are families, so 3 or 4 people per suite. And our challenge was to make about 2,500 gallons of hot water that they use in the building every day. So the Piranha HC works by recovering all the energy in the wastewater that's leaving the building. So as that warm water exits the building, it's been warmed up to about 75 degrees and a perfect source for recovering energy with a heat pump. So the Piranha HC is able to do, in the test, we were able to do 50% of the energy recovered, 75%, and 100% of the hot water heated to 140 degrees. So between our proprietary pumping technology for the storage tanks, we had about 1,000 gallons of hot water stored at 140 degrees in the building, but we also had about 2,000 gallons of leaving sewage in a tank so we can draw from it at any time. So the beauty of the system is that it's super efficient. We have real-time efficiencies of over 3.5, so 3.5 COP, producing 140 degree finished hot water. And the energy in the building is just recycled in perpetuity. So basically you use it, it goes down the drain, the Piranha HC recovers all of that energy and puts it back into the next batch of fresh water. So amazing use of the energy in a building. And once the cycle starts, all you do is you pay for moving the heat, not producing it. And the Piranha HC also offers simultaneously free air conditioning as a benefit of the operation. So we can provide full capacity for air conditioning as well. So with the COP of in excess of 3.5 all the time, year-round, regardless of outdoor air temperature, no defrost cycle, we were able to make that, thus offsetting the operation of the boiler 100%. So we saved in CO2 emissions in excess of 50 tons a year in that small building. And along with that, provided them with air conditioning. So the thermal benefit as well is that thermal energy doesn't leave the building and run into the adjacent ocean here and be part of the thermal melting of the ice caps, etc. So just by saving that thermal energy saved us from melting about equivalent of an American football field 70 feet deep in ice. And another part of the test was that we wanted to try out a new lower global warming potential refrigerant. So we used a refrigerant called R513A. It has a 60% lower global warming potential than the current refrigerant we were using of R134A. And so combined with that, the efficiency, the energy savings, the utilities can use the Piranha as a programming tool to offset the demand for electric hot water, because the unit only had to run about 12 hours a day to produce the 2,500 gallons of finished hot water. So it allows the utility to be able to connect into our very sophisticated real-time connection to the unit to program the unit to make hot water when it fits the grid pattern. So we think we've covered off all the bases. We had the privilege of working with Sylvia Crum from Con Edison in New York, and she's now going to talk about some of the thoughts she has for implementing a product like ours into their market.
Thank you, Lynn. Good afternoon. My name is Sylvia Crum. I'm in R&D Con Edison. Con Edison serves electric, gas, and steam customers in all 5 boroughs of New York City, including part of Westchester. New York City is a very dense city, and there's plenty of opportunity to recover energies used within the city. Con Edison is always looking for innovative way how to meet clean energy goals, which are particularly very aggressive. In New York State, we are looking to have 85% reduction of greenhouse gases by 2050, carbon-free economy by 2040. And from energy efficiency perspective, we're looking at the energy savings in specifically 185 trillion BTU of customer technologies energy reduction, and 5 of those are specifically through the heat pump deployment. So we always welcome technologies that can align with these goals, and we are willing to find suitable locations for pilots that could prove that this technology can meet these goals and or contribute to them. So specifically for New York, I think the suitable pilot location would be laundromats, where wastewater stream is much hotter than typical building, as well as the residential that provides a steady wastewater heat, and hotels, and as well as the condensate from steam customers. So we are excited to find out whether this technology can prove in a little bit larger scale, potentially looking for pilots. And I think from customer perspective, if we can provide solution where customer can replace existing HVAC technology with something more efficient that can save money, it does make sense. So specifically from 85% typical gas boiler efficient equipment being replaced by, let's say, 350% efficient shark system, which is a potential, it is worth to demo further.
I love it. Stop dumping energy down the drain. With Sylvia at Con Ed, this is a very popular project. You can see it on the chat. I'm watching the chat over in the live stream. There's a lot of activity on this project. So it was also one that had a lot of interest across our group of utilities. So we do expect that we'll have a lot of deployments come out of this first test. Steve, you have the honor of bringing us home with our last project.
I do, yes, Eric, thank you. And last but definitely not least is SwitchSource, a company that I'm proud to recognize as an alumnus of an earlier Ameren Accelerator cohort, as well as participating here in Incubatenergy Labs. SwitchSource creates power electronic solutions for dynamic phase balancing to help manage distribution system loads and improve power quality and energy efficiency out on the system. Let's hear more from Annie Haas and the Switch Source project team.
I'm Annie Haas, and I'm the program co-lead with Incubatenergy, and would like to introduce to you today Team Switch Source. And we're going to dive right in with some questions for the team about this project. Charlie Murray from Switch Source, would you mind introducing yourself and talk a little bit about your technology and why you wanted to join this program?
Absolutely. Hi, I'm Charlie Murray. I'm the president and founder of Switch Source. Here at Switch Source, we make power electronics equipment for distribution utilities. And right now we're developing a new technology called the Phase EQ for balancing power on three-phase circuits. And what this really means is when we look at the way that utilities deliver power to customers, they typically use three phases. If you look at that power pole, there's typically three wires across the top of it. And they use one of those wires in what's known as a lateral to feed a group of customers. So what Switch Source developed was a device that can actively balance the loading on these three-phase circuits from phase to phase and help mitigate some of the power quality and efficiency issues that arise as a result of phase imbalance. As we were working on developing this technology, we saw this great opportunity to work with Incubatenergy, work with the utility to perform a benefits cost analysis for this technology. So we're really relying on EPRI's expertise in power system simulations, as well as their expertise in benefits cost analysis, and then also having the help of a utility at the table to guide us in that work.
Thank you so much. Could you first introduce yourself, but also talk a little bit about the project and the importance of phase imbalance on distribution feeders?
Sure. Thank you, Annie. So my name is Jeremiah DeBoover. I'm with the Power Delivery and Utilization Group and at EPRI, and I'm focused on distribution system modeling and simulation. And so for, like Charlie mentioned, phase imbalance can become pretty severe on some feeders. And what that causes is that it can create voltage imbalance on the feeder as well as current imbalance on the feeder. And so one of the phase can have hit the limit of operation where a utility would need to address that issue before adding more load or having more customers. And this issue can be exacerbated by DER. So a residential PV can make that problem even more significant, where traditional solutions cannot be used to address that issue.
All right, next up, Cody Davis from Ameren. Cody, would you mind introducing yourself and talk about what solutions are out there for phase imbalance and how is Ameren looking at it?
Yeah, thanks, Annie. So my name's Cody Davis. I work in our DER integration group as a power systems engineer. Phase balancing on the utility side, typically we are most commonly physically moving taps from being connected from one phase to another phase to try to balance it. Typically, we're looking at one specific moment in time. So there's some issues that come up when that imbalance varies significantly over time. We also do some projects to mitigate some of the symptoms of phase imbalance, like overloads or voltage imbalance, by adding voltage regulators or replacing overloaded equipment. So our approach with this device was really to find high impact areas where phase balancing is causing problems and evaluate the phase EQ and how it relates and compares to those traditional solutions.
Awesome, thank you. Jeremiah, back to you. Could you talk a little bit about what you found in terms of the techno-economic benefits of this device?
Sure, thanks, Annie. So as EPRI, we wanted to have a techno-economic evaluation, so a cost-benefit analysis of the device and have an impartial view on the benefit that it would provide to the grid. So the first step in our cost-benefit analysis was to look at all the technical benefits that the device can provide in terms of balancing the phase voltage, balancing the phase current, helping with integration of DER, reducing neutral current, or any energy efficiency improvement that it would provide. We looked at all these technical benefits and to see if any of them could be monetized. and compare them to how traditional mitigation measures could be used to understand what is the economic or the business case for this device. There's some ideal feeders that we have identified in this study was a feeder that is a repeated offender of phase imbalance that needs to be addressed every year, or feeders with severe phase imbalance that cannot be addressed with traditional mitigation measures could benefit from having the phase EQ as a device, as a mitigation solution. Additionally, we also found that feeders with high penetration of rooftop solar could be problematic feeders for the utility, where the phase EQ could provide that solution for them.
So Cody, how has this project helped you guys, and where do you see it going next?
I think the project's been really helpful for us to see both the method and sort of get an estimate of the magnitude of the benefits of the phase EQ and kind of capture the analysis method for how we can look at where to deploy this thing. I think it adds a new tool to our toolbox as a new solution to an old problem. And I think that's been really exciting to see and develop, especially in the abbreviated time frame here. We've learned a lot and got a lot of work done in not a lot of time. So it's been very helpful for us.
So people can reach out to me directly. Feel free to just send me an email. We're happy to provide information, give you a little bit more technical background, specification of the equipment. We also have the same tools that we put into the hands of EPRI that we can give to distribution planners so that they can start playing with our devices in their modeling and simulation packages, getting a sense of how the phase EQ can help them on their systems.
Thanks, Charlie. Good to be working with you again and with your company, SwitchSource. And also a shout out to Rick Welton and his team at Ameren, Illinois. A lot of great support for this. And of course, to Jeremiah, terrific support from EPRI. Really great collaboration on this one. Looks like we've got some interesting use cases for field deployment, and I look forward to seeing what's coming next. So that concludes our presentations from our 10 startups. I want to remind everybody to really reach out via chat or get into the meeting rooms and talk with these companies. Again, this is what Demo Day is all about. And with that, Eric, back to you.
Thanks, Steve. Yeah, this has been a great day, great result of these 10 projects. We could have easily gone far awry with the COVID issues that we had early in the year. It's so great to see all these projects do so well. Been a super pleasure working with Steve and Ameren and the rest of the hosts and utilities that have joined us. So we're going to wrap up for the day before we shift over to the one-on-one meetings with our companies. With that, I would like to introduce Mark McGranigan, VP of Innovation at EPRI, to close us out with Steve.
Hey, Mark, you there? How are things in Dublin? Well, maybe while Mark's getting connected, I'll just say a little bit about, what do you got, Eric?
Back to us. I don't know if Mark has had some connection.
Okay. All right.
That's the benefit
of
real time.
No worries. You want to talk a little bit about the EPRI perspective, and then I'll maybe close this out from there, and we'll see if Mark's able to join us.
Yeah, sure. And I think the host is working on getting Mark back. So when it does, we'll get him back on. So first of all, from an overall EPRI perspective, as I mentioned, we couldn't be more delighted with kind of how things went this year. This is a great way for us to align our research priorities with the research and application priorities of our member utilities. It helps us understand the innovations that are occurring in the industry, and we can help apply them and build on them. We take a little unique approach with Incubatenergy Labs in that we try to run these quite rapidly. All these projects were 12 to 16 week projects. So we learn those key things about the project that will get them integrated in our systems, and that kind of opens up the learnings to all the utilities to get involved and understand how they might apply them quickly. It connects our subject matter experts with our member experts, with the innovation community, and ultimately makes everybody much smarter, much more effective in their roles. And finally, provides a means of accelerating the application of these new technologies and help us realize this vision of an integrated grid and integrated energy systems.
Yeah, I couldn't agree more, Eric. Absolutely. So I think I said in those opening comments that that Ameren is committed to being a host again. I would really encourage my utility brethren who are on the phone here to seriously consider that. There's really good benefits to it. You saw, the kind of engagement from my Ameren coworkers we were able to get through these. Lots of great learnings. Particularly happy to see some of the early stage. Jeff Hackman is not early stage, but we had lots of great early stage, coworkers that were engaged, with this. I also want to make sure before we sign off, I think Eric would probably agree with me that we would not have been able to do this project without the leadership of 4 key women behind the scenes. Well, we've seen a couple of them already. Annie Haas, Joyce Hawks, Danielle Wilsey, and Melissa Sullivan. I just want to thank all of you and the team that worked with you, but particularly you ladies for helping us out. I'm really already looking forward to 2021. We will be doing that pretty quickly, here. We'll do a little debrief on, what we did well this year and what we can do better next year, but we're going to be pivoting pretty quickly to 2021, right, Eric?
Yeah, that's a really good point. So we're wrapping up today. In just 3 weeks from now, we're starting to talk as the group of utilities about our innovation priorities and those challenges that we want to communicate for 2021. So if you are interested as a utility, you're not already involved in Incubate Energy Labs, I think we have all of our utilities coming back for next year. We'd love to have more in the group. So if you are not part of this effort, definitely join us. Reach out to me, reach out to Annie, or if you're connected to Mark or Steve, feel free there. They'll get you connected to us. You can be a host to host these projects. You can be a participant to collaborate with these projects and kind of learn as your peers are hosting those projects. And then, of course, for all of you that were involved in the call today, give us your feedback. This is an ongoing effort for us. We continue to improve it every year. We want to do the same for 2021. So feel free to provide feedback to all of us. And finally, the big push is just participate, right? The utilities that get the most value out of this are the ones that are deeply involved in projects. Again, whether you're hosting those projects or not. I saw in the chat some comments about Frank Doherty at Con Ed. He was one of those that didn't host a project, but he was involved in a ton of these projects week to week as they were moving forward. So great to see that participation.
Absolutely. Absolutely.
I think we're off to one-on-ones now. Is that right, Steve?
I think that's right, and we're pretty much right on time. So, go for the one-on-ones, collide in chat, keep innovating, and everybody have a great, safe evening, and we will see you for 2021.
Yeah, excited about that. So, for those of you...
Little bit ahead.
Sorry.
You got one more thing there. Go for it.
So for final directions there, we do have slots reserved today. There's still sessions open, so go over to the meetings tab, go over to the startup tab. You can set those meetings for this afternoon. If you don't have time this afternoon, go to that same one, those same tabs, you can set them up for future dates. If you want to have any of your colleagues review any of this content, something you saw that was interesting, the material will be live on this site for the next month and will be on the Incubate Energy Labs website after that. So you can come back and participate that way. So with that, we can go over to the credits.